Alright, welcome to the second new programmer video, and this one's going to be about command-based programming. So, the last thing you guys did, if you followed the first video, was you wrote what I believe is called timed robot code, or just iterative robot code. And you wrote code that works by having logic go through every single loop, and you're performing all the logic yourself, and it works, right? But it's not that clean, and it's kind of tricky to get the hang of. So command-based programming solves a lot of these problems, and here's a handy way. This website on WPI Live, you can find it, gives a good example. So what you'd have to do before is you have to use if statements, like if a button.get, or get raw button is what you used last time. Then you do all these logic checks with if and else statements, and then you'd have to handle things price equals true, price equals false, run your intake, use that, you know what I mean? All those things you'd have to do to run, let's say, your intake. In command-based programming, you'd define a button. You'd say when the button is pressed, run the intake. So it does simple things like this. This is why command-based programming is preferred, and it's significantly cleaner, and it's easier to add things that interact with each other, and they won't break each other, and it's really good for autonomous and stuff, which we'll get onto later. But to start with, what command-based programming really is, you really want to look at it like this. You have subsystems and commands. A subsystem is something like your drivetrain, like your elevator, like your arm, your shooter. In our case, we have the conveyor would be a subsystem. The intake would be a subsystem, and again, the drivetrain. Or if you had a swerve drive, your swerve drive, all four modules would be a subsystem. And those subsystems are where all of your motors are defined, like how you made those Talon effects in the last one. And out of those subsystems, you'd have commands. So an elevator would have a command move to scoring position. Your drivetrain could be drive forward and score, drive to goal. Then you could have the launch minibot stuff. This is probably from the year 2011 when you had to make a little robot that was attached to your big robot, I think. But other commands like this, so stow wrist. So these are all commands that are based on the things you did in these subsystems, right? So let's go into actual code. And what we're gonna do is we're gonna rewrite some of the basic stuff that you guys did, but as command based instead of timed. I'm gonna call it timed based, time based, because I don't know what else to call it. So the command scheduler is your god, right? So let's look at I made a meme. The command scheduler is your overlord. You bow down to the command scheduler. It does everything for you. It is an object in the code, is a thing in the code that lives on the robot that handles all the commands and subsystems and loops every single 20 milliseconds. So you are essentially at the command scheduler's will. You tell this command scheduler what you want to do, and it will do it for you, right? So you're going to say, I want to run this command now, and it's going to do all the logic that you've preset up to know when the command starts and when it ends. And it's just really important to know that everything really happens through the command scheduler. So instead of doing everything inside robot.java, inside teleop periodic and teleop init, we're going to move out of here and we're going to go to some other places. So right now you start with some folders, the command folder and the subsystem folder. They give you an example subsystem and an example command, and you can view them. But we're going to get rid of them because they're not necessary, and we're going to make our own. So if you have a project like this, I made a new project. I didn't show the creation of the project. You can do it the same way as before. Just remove, if you're using the same project, just remove everything you made inside robot.java because you don't want it to conflict. So I'm going to just get rid of these by deleting them because I don't need them. So we have no subsystems and no commands. And inside here, just if there's any errors. Right now, we've defined these subsystems in here, so I'm just going to get rid of them so there's no error. We're just going to comment this out. I'm just going to return a, for now, just you don't have to do this. I'm just going to return a sequential command group that's empty. Something you do not know yet, but it's just to fix the errors. I didn't realize it would do that. But the first thing we need to do, so I mean, if you have this error yourself, you can just type this in. Don't worry about it. You can just type this exact line in. You don't have to worry about what it does. It'll just get you through to the next step. So we want to make a subsystem first. I think a good starting place, as everyone might agree, is a drivetrain, right? So why don't we make a new drivetrain subsystem? So I'm just gonna, you could do two things. You could either click on this button in the top right corner and type in create. I'm sorry, is it create a project or is it like class? I don't know. I don't know what the command is, but I normally just right click on here and do create a new class / command. And I'll do it inside the subsystem folder. And I'm going to type subsystem. There's an old subsystem and a new subsystem. They changed in the year 2020 how the command-based stuff worked. You always want to do the new stuff. Don't worry, but don't do the old stuff. So we're going to make a new subsystem. I'm going to call it drive subsystem. You want to have a good naming convention for these files. It frustrates me when teams don't do that. So what we like to do on 747, Brian and I, we do drive subsystem, hatch subsystem, climb subsystem, elevator subsystem for previous years. But I like to do capital on the first letter and then subsystem. So drive subsystem. So what do we have here? We have a constructor for when this is initialized, and you have a periodic loop. So this periodic is just called once per every time the command scheduler goes through its loop, which is every 20 milliseconds, just like the teleop init and stuff. So that is our basic drive subsystem. So what do we need to do? The first thing we probably want to do is make some motors, right? So I'd already also, if you made a new project, make sure you do the importing the Phoenix stuff like before. So you don't feel like so you won't be missing the stuff, but I already had it, so I'm okay. So I'm going to create some new WPI talent FXs. On our drive train right now we have 6, so I'm going to do what I like to call them is left drive primary equals new WPI talent FX. I'm going to put it on 0. Again, we don't know what numbers these actually are. You can figure that out. But I'm going to call it 0, 1, and 2 for the left side, right? So we're going to create left drive primary, and I'm going to call it left drive follower 1 and left drive follower 2. So we're going to have one that's the main motor that we control, and one's going to be the follower 1 and one's going to be follower 2. So that's the left side, and I'm going to create the right side by the same thing. We're getting errors because they're the same names. I'm just going to copy this because I'm too lazy. Right. And we're going to give these numbers. I don't know what numbers they are on the real robot, so I'm just going to call them 3, 4, 5. But you know what I mean. You can figure out the IDs. The fact is now we have 6 motors. So what do we want to do with them? We need to go in. So the whole point is there's a few things we need to do when the subsystem is initialized, right? So when the motors are created, you did these inside teleop init before, or maybe inside robot init, but you could do them in here. So the first thing you probably want to do is you probably want to config the factory defaults of all the motors. Left drive primary. Oh, sorry. .config factory defaults. And we'll do this for all the motors, so I'm just going to copy and paste it down. But let's go like this. 3, 4, 5, 6. I like to put separations between the left and right things. So left drive. Let's just go like this. I can just copy and paste them. Copy, paste. So I'm just resetting right now all of the settings on the motors, because if something was set before, you don't want to be set there anymore from previous runs. So now, I mean, the thought is, I don't know what side of the robot's inverted. One side is going to have to drive the opposite direction because of the fact that they're mirrored motors. They're not both facing the same way. One's going to spin clockwise. They're both going to spin clockwise, and if you make them both positive, it would spin in a circle, the robot, instead of going forward. So thinking about it logically, I'm pretty sure that the left side has to be inverted, but I'm not sure about that. So I'm going to do left side, but if it turns out that it's going the opposite direction that you expect, like instead of the intake being forward, it's the shooter being forward, you can swap that to be right side, whatever you need. So I'm going to do left drive primary dot set inverted. I'm going to do invert type dot invert motor output. So the motor is now inverted. The next thing I want to do, oh, I'm sorry, let's do one thing before this. Let's make the motors follow each other, because the inverting is based on that too. So let's have left drive follower 1 dot follow, and we're going to have it follow left drive primary. This is making it so you only have to control left drive primary, and you don't have to worry about the other two on each side. So we're going to make the second follower follow left drive primary also. And we're going to do the same thing with the right side. So right drive follower 1 dot follow, right drive primary. Then we're going to do right drive follower 2 dot follow, right drive primary. Okay, so now we're following. So now we move on to this. So the reason I had to do that first is because we're setting left to be inverted, but we want to make sure we make the other lefts inverted too. So we do left drive follower 1 dot set inverted, and you could do invert type dot follow the master. So the master of this motor is the left drive primary. So it's gonna if it's saying do whatever type of inversion the one that you're following is doing. So if the left drive is inverted, then make this inverted. If it's not inverted, it wouldn't. So you could do it with this. We'll just do it like this. We'll do left drive that. I'm sorry, like that. And we're gonna do this. We can even do the same thing for the right side. We can just do. Is there even a no option for this? I think we could even just do this. Right drive primary dot set inverted. invert type dot none. So we're going to say we don't want right to be inverted. The reason I'm adding this in here is because if you want to swap them, it's just easy code to change. So I'm going to do right drive follower one dot set inverted invert type dot follow master. And we'll do the same thing for right drive follower 2. Okay, so that's good. Now we've got some good basic setup. What else do we need to do? We did the left inverted. We did the followers. Okay, so that's pretty much it for like basic stuff that you want to do inside of your constructor. You can do other stuff. Like you can do current limiting, so you can set the maximum amount of electricity, voltage that can be drawn by a certain motor. So like if you wanted to do that, you don't have to do this. I'm just showing you. You can do left drive primary, not config, nominal, output forward, and you could put in the what you need it to be, or peak, and all. There's all sorts of settings on the on CTRE's documentation if you want to read that, or you could just ask us and we'll tell you. But it's just basic stuff like that. So that's good for the constructor. What else should be in here? We should probably make a function that is a way for us to control the motors, because we don't want to. Right now, we should make these private, probably too. These should be private, just because we don't want people to accidentally control them. I forgot to copy the space. So we don't want people to. It's bad practice to do the subsystem dot the motor. You probably want to make methods that access the things instead. So why don't we make a setting method? So let's make public void. Void meaning it's not going to return anything, and we'll make the method set, just like that. And inside set, we'll take in 2 inputs: double left speed and a double right speed. So all this is going to take in is going to take in 2 speeds, and we're going to do left drive primary dot set. Dot set control mode dot percent output left speed. Right? I'm sorry, that's not the variable is called left underscore speed. And then we can do the same thing with right drive primary. Not set inverted. We just want to do set. Oh my god. There's too many. There's all these different versions of this function, but we don't care. So right speed. Okay, so we've just made a setter thing. So if we wanted to, let's say, technically we could go into robot.java and set robot.init. If we created an instance of that subsystem, we could do, let me see, where's robot.init? This is not going to work because I haven't actually created an instance of that subsystem, but we could do whatever we called the instance of the drive subsystem. We do drive subsystem.set 1, 1, and that would set the motor speeds to be full on both sides. So that's just a way you could control. Now, there's probably one other thing we want to make in here. That's pretty easy. Just make a stop function. Public void stop. And we can just do left drive primary dot set. I don't know why it's making all these other like demands in here. Control mode dot percent output. I'm just gonna get rid of all of this because we don't. These are just other ways that you can control the motors. We only care about the one that takes in 2 inputs. So we're gonna say set both of the motors to 0. Just stop the motors. It's just this is just a handy function that I find myself using in a lot of commands that we end up making. So that's that. Right, so right now you've created a subsystem that can control the motors and stop the motors, so that's good. Now that we've made the subsystem, this is not going to do anything because this subsystem just exists. You know what I mean? It just lives in our code. It doesn't do anything right now. If you push the code to the robot, I don't think this would even exist on the robot because it's not accessed anywhere. So there's a class that we use called robot container. Robot container is where we do a lot of the commands and subsystems and button stuff. So the reason that robot.java exists, and you think that that's like where the heart of the robot is it's really just a spot for these handy loops that you can use. So inside like teleop periodic, I can maybe make it. Let's say I want to make a printout of something, and I wanted to print out like the game time or something. I want to print out the computer time. I could do system.time nano current time millis or something, and that's going to print out the. I have to import smart dashboard, I guess. I'm sorry, you have to do a put number. But it could be like this. You do something like that. And the reasoning for this is that maybe you want to just have it constantly printing out during teleop. And this does not make sense to go inside, this printout does not make sense to go inside any of the subsystems specifically. You just want it to be when the robot's enabled. That's why these loops are here. It's just so you could use them for stuff. We're not actually going to use them though. You really don't use them that often once you use command-based programming. The robot container handles a lot of it. So Let's see, what do we have here? We have a few methods. This constructor, all it is just when the robot container is defined. I believe it is defined inside robot.java. So you can see it's just in here. But when it's defined, it'll call configure button bindings. So if you make any buttons, you put them in there. And we're going to want to create our subsystems in here also. So why don't we make a subsystem? Let's call it drive subsystem. Now the naming convention we used on 747 was, I don't know why we did this, but it was just we use all capitals, and with the word we put an underscore in between the words. So I'm just going to call it this. I just like doing it this way. You can do whatever naming convention you think is the best, though. Just keep it the same. So we've created our drive subsystem, and that's going to call the constructor, right? Because the constructor is called right here. So at least we know that these motors are going to be defined, and all of these things are going to be ran. So still, there's nothing actually controlling the motors, right? So we need to make a command that controls these motors. So why don't we create a command? We're going to right-click on the commands folder. You could technically put it anywhere, but the command, keep it organized. And I'm going to create a command. We're going to create a new command, not an old version command, a new version command. And I'm going to call it default drive command. So how this is going to work is we're going to have the constantly throughout teleop, while the robot is enabled, the robot's just going to be waiting for a joystick input to drive the robot. That's it. That's all it's going to be. So we're going to just create a command, right? So let's think. What do we need to take in this command? There's a few things. So you see where it says right here, add requirements to declare subsystem dependencies. The whole point of this is we want to tell this command that it needs to use the drive subsystem. And what that means is that if any other command tries to use the drive subsystem also, it's going to stop the default drive command, because it's also they're both using the drivetrain subsystem. When you tell it to add requirements, it's going to physically stop one command and start the other, so you're not controlling them at the same time. So let's say you had a command that drives the robot forward 100 inches or something. If you're driving with the sticks and then you press the button that would schedule the 100 inches command, if they both require the drive subsystem, it's going to cancel the default drive command and do the 100 inches command, and when that one's done, it'll put back control to the default drive command. It handles it all by itself. You don't have to worry about it. So if we want to add requirements, we're going to need to pass into this class a drive subsystem. So I'm just going to call it drive, just as a name. And we need to, this is just good coding practice. You want to, this is this injection? I don't remember what this is called, like object injection or something. So you want to create an instance of the class inside here. Equals new drive subsystem. I'm sorry, you don't want to initialize it. You want to leave it like that. And then you want to do this dot drive subsystem. So you're going to say the instance of drive subsystem that's inside the command is going to be equal to the version that's passed in, right? When we declare the class, or when we declare the command outside of this. And this is just it allows us to access the actual drive subsystem that we declared inside here through just by typing drive underscore subsystem. We won't have to type robot container. That's how I spell robot container. You would otherwise have to type robot container dot drive subsystem dot whatever you're doing. Now you can just type drive subsystem, because we passed in the thing already, and we can just access it through that. So there's another thing we have to pass in. That's going to have to be a joystick, right? Because we're going to be controlling this robot using a joystick. So I'm going to pass in a joystick, and we're going to just call it controller. Maybe we'll just call it con, just to shorten the name. And then we'll make a new joystick up here. I'm sorry, this should be private too. All these things should be private, really. Joystick. And we're going to call it controller. And we'll do this. Controller equals con. Again, if you have any questions, just ask me about them, or you can leave them in the comments if you need to, but you can just ask me in person or message me on Discord. We've defined these. We want to add the requirement now. So we're going to do add requirements, and we're going to type in drive subsystem. So now what we're saying is this command requires the drive subsystem to be in control for this to work. So no other commands can be using the drive subsystem at this time, or else we're going to have conflicts. Imagine if two commands are running where one is setting it one way and one's setting it the other. You're just going to have this awful noise of the motor trying to change directions 60 times a second, right? So that's good for this, I believe. Now let's move on to the other parts of this command. So when this command is scheduled, it's going to have an initialize function. So that's right when it's called. or right when it starts. So that would be when when teleop's enabled, or if another command takes over the drivetrain and then relinquishes control back to it, that it'll run again. Execute will run every 20 milliseconds while it's scheduled. So this is where we're going to be doing like the updating of the motors. End is going to be called if the command ends. So if we have like logic here that would end the command, which we don't, you'd put it in there. The end thing otherwise is just going to be when it's interrupted, really. So if you have another command that takes over the drive subsystem, it'd call end at that point. So let's think, what do we need to do? We want to have this thing drive the robot like normal, right? So why don't we just make two variables? We're going to make double left equals, we'll do double left and double right. These are just the speeds on each side. Let's do left equals 0. We're just going to initialize them in here. Right equals 0. The reason I'm initializing them in here is because if you initialize them up here, if the command is stopped and then rescheduled, then it's not going to be reset when it's called a second time. So why don't we also do a smooth control setup, right? So I believe that's called a, what is that called? That is called a, let's see, this is a good example of how we can learn things. Smooth joystick input WPIlib. There we go, smooth. And I believe that the term is, it's like smooth input FRC WPIlib. It's a way to, it says 3 words. I don't remember exactly what it's called. It is a specific type of input. How do I not know what it is? Oh, here it is. It should be here. Let's scroll down. Not differential drive. Not mechanical drive. Not field oriented driving. Man, I don't even remember the name of it. Is it? One second, I'll figure it out. I figured it out. Slew rate limiter. I don't remember how I didn't remember that. So let's define those two things. A slew rate limiter, what it does is it makes your joystick inputs more smooth. So if you're at 0 on your joystick and you go all the way to 1 immediately, like in a millisecond, it changes the maximum amount of change in that value to a certain number that you type in. So if you make the maximum rate 0.5 per second, if you went from 0 to 1, the robot would take 2 seconds to recognize that the input went from 0 to 1 because you have a maximum rate of change of that of 0.5. So it just smooths out your inputs. You can make that a lot smaller though, or bigger, or whatever makes it quicker. So let's do that. Let's just create a few slew rate limiters. Left limiter. Then we're gonna make a new slew rate limiter. Equals right limiter. And again, let's follow the tutorial on here on how to do it. It says right here, the next thing, they have a great example code. It says to, oh, we can just initialize it. That's fine. We don't have to do anything. So we're just going to initialize it as a new slew rate limiter. And then here you type in the rate limit. So this is the amount of units that can change in 1 second. So I'm going to make it 1. Okay? So I'll explain what that means. So what this is saying is that the joystick input that we're going to give it will take 1 second to go from 0 to 1. If I made it 0.5, it would take 2 seconds to go from 0 to 1 because it can only increase by 0.5 at most every single second, right? The higher this number, the snappier your thing's going to be. If you made this 0.1, the maximum joystick change will be 0.1 units per second, which means it'll take 10 seconds to get from 0 to max if you did it really quickly. The robot would slow it down to take 10 seconds to get there. So we're going to make it 1. This will just make the driving feel smoother. And you can make this even quicker. So if you make this 2, it'll take half a second to get from 0 to 1. It's just a way to smooth out your driving. So again, the next thing you have to probably do is you're just going to go down to the thing right here, and we're going to set the motor outputs, right? So inside here, we're going to do left is equal to our controller dot get raw axis, right? And I'm going to say I remember the y-axis was 0 on one controller, and I don't know what it was on the other side of the stick. Maybe it was 4 for the other one, but you can decide what that is. I'll make it 5. Maybe that's the other y-axis. This is like left y-axis. This is right y-axis for your controller. We're doing tank drive, by the way, not arcade drive. If you can change this to be arcade drive, that'd be cool too. But you know what I mean. So we're gonna have these be the inputs, and then what we're gonna say is we're just gonna do drive subsystem dot set, right? See, this is the whole point, is we can just access the drive subsystem in the set method. We need to give it a left speed and the right speed. To get the speeds, you need to pass them into the slew rate limiters, the joystick values. So we do left limiter dot calculate, and we just pass in the left joystick value. And what the left limiter is doing is it's returning basically the smoothed out version of whatever you're passing in. So we're gonna do right limiter dot set. Or I'm sorry, let's not calculate. Right, just like that. Okay. So now this is just gonna do this every single loop. That's all it is. And these are both positive because we inverted one of the sides. You don't have to make one of them negative. Okay. And the last thing we want to do is if this command ends, so if something interrupts it, right now we don't have anything to interrupt it, but it's good practice, is just to do drive subsystem.stop. So if the command is stop, it'll stop the motors automatically. Because if you otherwise the command wouldn't stop the motors if you kept running. So that's that for the entire default drive command inside of it. Let's move back to the robot container because we have to do something. And that is we have to declare that this command is a default command. Now, where do we want to do that? I personally like to do it inside its own method, so I'm going to create a private void. I like to call it, what do we want to call it? Default commands. And this is a default command is a command that runs in the subsystem constantly. It's not going to stop. If there's no other command running on the subsystem, it'll run this command. Basically, it's the default command. So what we're going to say is we're going to do drive subsystem.set default command, and we're going to want to give it a instance of the command. So we have to pass in a command. The one way you could do it is you could do default drive command and just call it default drive command equals new default drive command, and you need to pass in a drive subsystem. So drive subsystem and a controller, which we don't have. We need to make a controller. On port 0, right? You made a joystick before. Again, make these all private. Now, you could just do it this way, and then you could pass in default drive command down here. That's one way. However, there's a significantly cleaner way to do it. I'm sorry, let's take a semicolon. And that would just be to basically create a new instance of the object and pass it right in. So let's just get rid of this. And we're just going to do new default drive command. And we're going to pass in the drive subsystem and the controller. Just like that. So it's basically we're creating the instance of that command without giving it a name. Because we're never going to access it outside of this. So this like this. Now we set the default command. And we want to call this inside robot container. So default commands. So when robot container is created inside robot.java, it's going to configure the default buttons and it's going to schedule the default commands. So that's good. Now let's think. What else do we want to do? You probably at this point should be testing, right? You want to be testing through this whole thing and making sure it builds. And at this point you can push and you should have a driving robot if you enable teleop. But what else do we want? Why don't we mess around with a motor and try to make a button? Right? A toggle button. How about that? Let's do a new subsystem. We're going to need a new subsystem. Why don't we make the intake? So I'm going to create a new subsystem. We call it intake subsystem. Okay? And inside of this, let's make a new motor. So I'm going to create a new WPI lib. WPI underscore talent effects. I'm going to call it intake motor equals new WPI talent effects. I'm going to give it the number 6. I don't remember what number it was, but you can figure that out. And we're going to do the same stuff we did inside drive subsystem, but to this motor. So I'm just going to go, I don't even need to copy and paste it. Let's just do intake motor.config factory defaults. And I don't think that there's anything else. Let's just reference this. We don't have any followers. We don't have any inversion. You can set the inversion in here if you want to, but you don't need to because you just it should be going one direction. So we've done that. Let's create another thing. Let's do the set and the stop function. So public void set, and it's just going to be a double speed. And we're going to do intake motor dot set control mode. Nope, not that. Control mode dot percent output. And we're going to get rid of the rest of this junk. We want to make it that speed. So this method is just an easy way to... It allows us to not have to type that every single time. I accidentally imported that. Let's get rid of it. The next thing we want to do is just probably stop also, right? So public void stop. And we're going to do intake motor dot set control mode dot percent output comma 0. Okay, so that's all the stuff we did with that. Let's go create now an instance of this inside robot container. So I'm going to create private intake subsystem intake underscore subsystem equals new intake subsystem. Okay, so we've now created an instance of the intake subsystem. Now we're not doing anything with it, right? So where do we want to use it? Oh, I'm sorry. There's one other thing we have to do inside this intake command. Inside this we haven't made the intake command. What am I saying? Let's make the intake command. Let's make a. Do we want to make a toggle intake on? A toggle might be a good idea, or just a while held might be fine. So let's just do a while held. So we're gonna create a new command. I'm gonna just call it intake. I'm gonna call it run intake command, just like that. And we're gonna have to do just like before. We're gonna want to pass in the command or the subsystem. So we're gonna do intake subsystem intake. We're gonna create an instance of this thing and set it equal. This is called like object injection. I don't remember. Is it DIP, OIP? I don't know. DIO. I don't know what the direct object injection DOI. Something like that, where you want to pass the objects in and then access them from inside instead of doing like static referencing by doing robot container dot whatever. So let's just create a new instance of intake subsystem. Sorry, always make these private. System equals new. I'm sorry, not new. I keep forgetting this. It's not new. It's gonna be, the whole point is that we're gonna be doing this dot intake subsystem is equal to what we're passing in. And then we want to add the requirement, like before. We want to say that this is requiring the intake subsystem. So no other commands can run the intake subsystem while this is running. Or if it is going to run it, it's going to cancel this one. So only one command with the intake subsystem can run at a time. So that's good. The next thing we want to do is we want to say, well, what is this command going to do? While it's enabled, so while this is being held down, we just want to keep setting the speed to be on. Right? I mean, that makes sense. Technically, you could just, since it's only going to be setting the speed once, it's not going to turn itself off, you could probably set the speed inside initialize. But then if the motor turns off and turns back on, I'm not sure if it would be reset. So I'm just going to do it inside execute, so it's constantly telling it to go to whatever speed you want it to be. But that's just up to you. This just seems like a safer bet. Like if a motor turns off because the temporary loses power somehow, it'll be able to reset the speed to full. So let's do intake subsystem. This is the whole point. We created that set command before, and why don't we set the speed to be 70.7? I don't remember what number was good, but 0.7 seems like a fine speed. Then that's just going to set our speed, and then the whole point is at the end we're just going to do intake subsystem.stop. That's it. So I don't know if I explained this before, but the is finish, what it's doing is this returns true when the command should end. So let's say you have a command that's running and you're not making it just on like it's a button press but not a hold. You could make it do. You could do something like this. You could make a. Let's say you had a current measurement or something. So like you could measure on a wheel how much current is being drawn, and if you're stopping the wheel with your hand, it's taking more current to make that motor run. So you could measure in code how much current the motor's drawing, and you could do stuff with it. So I remember on Sereth was telling me that on the 2019 robot, they knew that their elevator was at the top of its extension when the current draw was really high because it took a lot of force to get it to break. You'd end up be breaking. You'd physically be like bending the robot at that point. So when you knew the current was high, you knew that it was doing something that it shouldn't be doing, so you'd stop the robot. So what you could do is you could do intake motor, intake subsystem dot. You could make a method, let's say get current, and if it's greater than some number, let's say 10, this would be 10 amps, it's going to return true. So this is returning whatever the result of this Boolean expression is. And if this ever returns true, saying that the current is above some amount of amps, then it's going to end the command automatically. It would stop the command because this is finished is called every 20 milliseconds to check the logic in here. And it would run the end at that point and do the stopping. So right now what we have is it's returning false. So the command is never going to end by itself. You know what I mean? The only way it's going to end is if you either press the toggle again, or if we're doing a toggle, or if you let go of the button if you're doing a while held. So that's that for now. Let's go back into the robot container. Now, if you think about it, does the intake subsystem have a default command? I don't think it does. I would say the intake subsystem does not have a default command. There's nothing you want it to do when the button's not being pressed, right? A shooter, you might want the wheel to spin really slowly. Like 254 makes their shooter wheel spin slowly so everyone knows the robot's enabled. That's one thing they do, but we don't care about that right now. So let's think. We need to define a button for our joystick, right? So let's create a button. I'm gonna create a private joystick button equals new. I'm sorry, we gotta give it a name. Let's give it a button equals new joystick button. and you need to give it the joystick that you're using, and you need to give it the button number. And the button number is just the ID, so I would make it 0 is probably A. I don't remember, but again, these are things you can figure out. Now we have a button. What do we need to do? Inside configure button bindings, where we're going to want to do A underscore button, and then you do dot. There's a few things here that you can see. If you type in toggle, you'll see toggle when active. Toggle when press is one of them. You can see when pressed, when active. These are all different logic. So when released, run this command. When pressed, run this command. All sorts of things. My favorite one, the best one for this is probably going to be when pressed. So when this button is pressed down, start the command that we just created, which is run intake. Was it run intake command? So we're going to do new run intake command. Again, you could have created one up here, but there's no reason to. You're never going to use it again. So just do a new command inside of here, and it takes in the intake subsystem. And with that, you're now taking an input from this, and it's gonna handle the logic by itself. When the button's pressed down, it's gonna run the intake. When you let go of it, it's gonna release the intake. Now you could even do a toggle. If I change this to toggle when pressed, so it's gonna turn on the intake when I tap it and turn it off when again. So remember, I know Griffin was with me. He did the latching code, the long latching logic. This is all in there automatically. You don't have to write that code anymore. It's done. You don't have to worry about it. So I want to put it back to when pressed because that's really better. But that's that. You could add to a few things you could do. So you can technically inside of Smart Dashboard, you could be printing out inside the drive subsystem. This periodic is inside the there's a periodic inside every single subsystem that's running that you could do like debug stuff with. So I could do like Smart Dashboard.put number. I could make like left motor speed. I could print out like the speed. So I could do like left drive primary dot get selected sensor velocity. That's a method that returns that's a function that returns the speed in what is this? Selected sensor per unit 100 milliseconds. So this is the speed per 100 milliseconds of the wheel in RPM or whatever the unit is. I think it might be ticks, which is another way of measuring. And you can do stuff like that. That's one thing. I'll even do it this way. We'll do right motor speed. Right drive primary. And here's one other thing you could do. This is a little more complicated. You have been working now with time-based stuff. You have not been getting any feedback from the robot, right? Let's think about this. We want to get feedback from the robot so we know what the robot is doing, right? We want to be able to tell how far the wheels have spun, and we want to be able to do math with that and maybe even speed up or speed down the robot based on how far the robot has driven, right? That's just for autonomous stuff. How do we access what's called the encoder, which is a built-in sensor inside of the motors, the talons, the Falcons, how do we access that in code? The sensor itself is called an encoder, right? It measures in ticks. So one rotation of the wheel, one revolution, is either 2048 ticks or 4096 ticks. I don't remember what the resolution is. So if one rotation is 360 degrees, I can even open Paint and do a quick drawing. If one rotation is 360 degrees, like that, the robot would measure from 0 to 2000, I think it's 2048 ticks. So if the wheel spun only halfway, like if it went from here to here, right, from starting from here all the way down to here, you would measure 1024 ticks. If it went somewhere in here, let's say, you'd measure somewhere between that, maybe 1600 ticks. And if you went, let's say, 2 revolutions, you'd measure 4096 ticks. If you went 100 revolutions, you'd measure 2000, or what is that, 24800. 204,800 ticks, right? So it's a useful way to measure your robot. You can do math with that. So let's create a method. I'll create 2 methods for you just to show how it works. I'll create 3. We'll do 3 things. One, we're going to get the left side. So we'll do public double get left position. I'm not going to show you what to do with these. This is up for you guys to figure out or ask us what you can do with them. And it's also that's like autonomous as a whole. I'm still learning autonomous, so it's not like an easy answer. But let's do get left position, and what it's going to return to you is it will be the left drive primary dot get selected sensor position. So this is just going to return, if I hover over it, you can even read it, get the selected sensor position and raw sensor units. Raw units is ticks. So this is just going to give you back the number. And then we'll do the same thing with the right side. And we'll do right drive primary. And then maybe we'll do one more. So you think, okay, well, this is going to give us the current position of each wheel. And the last thing you probably want to do is a function that'll reset them both to 0. Just because if you ever want to reset them during the code, it would be tedious to do the math to figure out where you are currently and then subtract it all. So let's make a zeroing one. Public public void 0. I'm just gonna call it 0. I think you would do left drive primary dot set selected sensor position and make it 0. So we're gonna say now your position is 0. And we're gonna do the same thing for the right drive primary. Just like that. So now we've reset the encoders with this thing. So what I would do is I'd say when the robot is initialized, or when the constructor is made, let's add something down here. Let's do 0. So we're going to 0 the encoders on the little sensors when the robot is enabled, right? That's a good idea. And we can even add a printout here. So we're printing out the speeds currently, but let's also print out the position of each wheel. Let's do left motor position. We'll do get left position. And we could even do this. Smart. I'll just copy and paste it. I don't want to. I'm too lazy. Right motor position. Get right position. Just like that. Okay. And that's going to print it out the entire time. Otherwise, that's pretty much it for basic command-based programming. It's not that complicated. It's a lot cleaner when you look at the code. Right now we have a nice drive subsystem with everything related to that in there. We have an intake subsystem. You should make a subsystem for everything on the robot. A shooter subsystem, a conveyor subsystem, a gate subsystem, whatever you need. I mean, really, I'd put the gate inside the conveyor thing. They're the same. You could put them inside the same thing. Maybe you give them separate methods, but they could be in the same, the conveyor and gate. Like maybe ball transfer subsystem. I challenge you to do all the code that you wrote with timed robot code before, now inside command-based, and see how you feel about it, and create a subsystem for everything. After that, continue with autonomous stuff. Otherwise, that's pretty much it for command-based programming. So, again, thank you for watching and taking the time to go through this video if you have. And, yep, that's all. Thanks.